In this video, I'm going to explain how to complete this week's activity, which is activity 7. This week's activity is on the same topic as the discussion questions, which is binomial probability, more specifically, binomial expected value. And, and when we were doing this week's discussion questions, we were learning about how the observed outcome is more likely to be close to the expected value when there's a large number of trials. And in this activity, I'm hoping to have you demonstrate that in a real life, real world situation. So I'm going to have you looking up some information about famous people online once again. But first, I need to explain what you need to do to get started. So first of all, you need to open up a blank spreadsheet, a Google Sheet, like I have here. And right here in the top left box, type in 4 siblings. And then down here, type in celebrity, or just, this will just be it just has to be some type of famous person. It doesn't have to necessarily be a celebrity. It just has to be someone you can get public information about online through a web search. And over here, type in number of males. So what I'd like for you to do here is look up celebrities that have 4 siblings. So actually, I want it to actually be 4 siblings, including the celebrity. So actually type in 3 siblings right there. So including the celebrity, it's 4 people who are siblings, 4 altogether. And then under here, look up a celebrity online who has 3 siblings and count the number of males within that group of 4 people. And it'll end up being some number between 0 and 4. And right here, type in the celebrity's name that you looked up, and it can be any well-known person who happens to have 3 siblings, as long as you can get the public information about them. And here, type in the number, and it can be anything. Like, let's say it might be 3 siblings. I'm just making that up. Or I mean, sorry, it might be 3 male siblings, but I'm just making that up. Because remember, you're recording the number of males out of 4 right here. So what we're saying here is that this celebrity has, this celebrity has 3 siblings, so it's 4 siblings altogether, and out of those 4 people, it's 3 males. And then look up another one who has another well-known person, and it can be anyone as long as they have 3 siblings. And then, once again, count the number of males within that group of 4 people, and it'll be some number between 0 and 4, and enter the number of males here. So let's imagine that in this group of 4 siblings, there are 2 males out of 4, so it's 2. And let's look up another one. So look up another person, and it can be anyone you want. Type their full name right here. Let's say that this person has 4 siblings. And keep going until you have a total of 15 people. A total of 15 celebrities who all have 3 siblings. So this should be 15 altogether right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. One more. And just keep recording the number of males within the group of 4 siblings. And remember, it includes the celebrity. So if the celebrity is a male, that would be counted as 1 male in this count over here. because like I said, the celebrity does count as one of the four. Let's imagine that this group of four siblings are all male. That would be a four. And just keep going until you finish. I'm just making up some numbers right here. And then go up here to the top. And right here, type in right here, type in 5 siblings. So now what you're going to be doing is you're going to be looking up celebrities who have 5 siblings. And they can be anyone you want, as long as you can get the publicly available information. So these are going to be groups of 6 people who are all siblings, because the celebrity counts as one of them. And here, type in this, have another column for the celebrity's name. And once again, type in record the number of males for each person. And do it for another 15 people. So go all the way down to the same row right here. So you're going to have another 15 celebrities. Each one of them has 5 siblings, and so each one is just a different group of 6 siblings. And for each of these groups, you're recording the number of males out of 6. So let me just make up some numbers again. And I said that these celebrities can be anyone you want, but they have to be people who aren't related, because you can't have 2 celebrities inside the same group. That would throw this off. So once again, let me just make up some numbers here. Each number here can be between 0 and 6. And at the bottom, I need you to make a graph for the first set and the second set. And I'll show you how I'd like for you to do that. So over here, type in 4 siblings. No, I'm sorry. Type in 3 siblings. And it's actually groups of 4 people. And under here, type in the possible outcomes, which are 0, 1, 2, 3, and 4, which is 4 males out of 4. And then I want you to label the expected value. So in this case, the expected value is 2 out of 4. Because remember that the expected value is n times p. We talked about that on Tuesday. So n is the number of trials, and p is the probability of the event. So in this case, if you have a group of 4 people and you're counting the males, each person has a 0.5 probability of, well, not exactly, but a roughly 0.5 probability of being born biologically male. And we're just going to round it off to 0.5 for the purpose of this activity. So that means that n is 4 and p is 0.5, probability 0.5. So it's 4 times 0.5, which would be 2. So what that means is in each group of 4 siblings, the expected number of males is 2. That doesn't mean that each group of 4 is going to have exactly 2 males. It just means that that's the most likely outcome out of all of these possibilities from 0 to 4. And outcomes further from 2 are less and less likely, like we talked about on Tuesday. And what I'd like for you to do is make a histogram that plots these numbers. So first of all, you have to count the number of zeros. So let's imagine for a moment that in this column, for number of males, in column B, we have one group who ends up having 0 males. So just highlight this in a certain color. You can choose any color you want, but I'm choosing blue as my color. Let's imagine that there's 2 groups that have 1 male out of 4. So you would highlight these both in blue. And imagine that there's 3 groups that are all male. And let's say 2 groups that have 3 males. And maybe 1 group that's 4 out of 4 males. And then what I'd like for you to do next is make the same type of histogram for this other group that has, for this other set where we're looking at groups of 6 instead of groups of 4. So type in 5 siblings. And type in the possible values, which in this case go from 0 all the way up to 6. And again, label the expected value. This time I'll let you figure out what the expected value is, but it's one of these numbers between 0 and 6. And for whichever one it is, type in expected value, like we did up here. And then remember it's n times p for expected value, and it's some number between 0 and 6 in this case. And then make the same histogram with by using the colors, but this time do it for this other set of numbers. For this column E. And now you'll have 2 histograms, one for the groups of 4 and one for the groups of 6. And once you've finished these 2 histograms, give this spreadsheet a name. You can just call it activity 7. And then answer the follow-up questions that are in the Word file that goes along with this activity. Because there's some follow-up questions. And then upload both the spreadsheet and the follow-up questions. So you'll have to download this as an Excel file and upload that, and then upload the follow-up questions as either a Word file or a PDF. Make sure it's not Apple Pages because I'm not able to open that format. And you do your best to pick your celebrities in an unbiased way. So try to make it as random as possible, because if you're picking and choosing people, you'll get a biased sample and you might not end up getting the outcome that we're expecting. For example, obviously, if you picked celebrities that have all male families, that's obviously going to throw off your graph because your histogram will only have 1 column. But so avoid doing something like that. Make sure you're picking them in an unbiased way. And that's it for this video of the spreadsheet. Just let me know if you have any questions.